thing in DNSSEC, DNS about registries and registrars and registrants. They love the prefix regist. It's really weird. I am not going to hit you guys with that. You'll walk out. Questions like how do you handle rollover and expiration? How do you keep clocks in sync? This is actually a fascinating problem. And if I had 2 or 3 hours, I'd love to go over it with you. But instead, there's going to be far more complete slides posted on recursion.com. Check them out, or come bug me after and hit me with all the crazy stuff. Believe me, we've been thinking about this stuff because we're making some pretty big bets that this is how we're going to secure the internet. At least against a portion of its problems. DNSSEC does not solve everything. So, towards the domain key infrastructure, how do we actually do PKI, but this time it works? Perhaps DNSSEC is easy to deploy, but so what? Distributed authentication is only interesting if it provides end-to-end semantics. Meaning, I've got a machine, I've got a desktop, I've got a phone, you've got a machine, a server, or whatever, somewhere in the cloud. I want to have an end-to-end connection, meaning I don't want to have to trust my local name server. Isn't trusting your local name server and hoping for the best the model of DNSSEC? Now, some people thought it was. The basic mode in DNSSEC is what's called the AD bit. And what the AD bit says is, oh, hey, client, check it out. I actually securely resolved this name. It's cool. You can trust it. Yeah, so? Look, I know Starbucks. I like Starbucks. I drink their coffee. I'm not trusting Starbucks to tell me the certificate of my bank. This I am not going to do. So no application on earth is going to alter the user experience based on the AD bit. What do? It's not enough to just trust. By the way, if you're not familiar with the architecture of DNS, I better explain it now. So the deal is you have this hierarchy, you have to go around between Alice and Travis and so on. Well, that's a lot of work, especially if you're a machine from 1983. So what we did is we had these servers called recursive resolvers. And they go ahead and they bounce around and do all this work. And then they come back and they're like, hey, I heard that Alice's number, that Jenny's number is 8765309. This becomes interesting in DNSSEC because here's the question. Do you still go to that recursive server and say, hey, go around and get me some information and tell me what you got? And the answer is, well, if he can be useful, if he can tell you things you actually want to know with a full trust chain, maybe. But at the end of the day, you don't trust him. You want to know and validate for yourself, or you're just going to have to do it yourself. So how does this end up working? How do we get full keys out of DNSSEC from some server on the internet to the phone in your hand? It turns out there are 4 mechanisms. They are chasing, tracing, wrapping, and packing. Let's go through each of them one by one. Chasing, going up the stack. When you have a signature, a so-called RRSIG, say you have a signature for www.foo.com, that signature says who it's signed by. So www.foo.com was signed by foo.com. Foo.com says, oh yeah, I'm signed by com. Com says, oh yeah, I'm signed by root. And then you were sitting there and you know how to recognize the root because the DNS root, as of 2 weeks ago, was finally signed. So now, if you're a chaser, if you're a chasing validator, you don't need to have all these intermediate keys. You just keep hopping back up. You go from the foo signature to the www signature to the foo signature to the com signature to the root signature, and you're done. This works and is implemented in LDNS today, and it takes about 10 lines of code. There's going to be a full sample kit and API implementation in the Freebird release package. But basically, it's a matter of running a few calls. What's the result? Well, here we go ahead and we're sitting at a desktop and we say, please chase back spooky.navy-dot-mil.org, and we chase it all the way back. LDNS is so nice, it even renders the pretty picture that you can show in your slide decks at Black Hat. Cool. End-to-end trust. Now, there are two problems with chasing. First of all, it requires you to go back and forth with your local name server. Your local name server is going to keep giving you these little slices of what you want to know, but you have to keep asking. Now, if your name server is on your local network, big deal. But say you're using OpenDNS or Google DNS, the distance between users and their servers is increasing. It's getting slower. And as Paul Vixie says, there's no way to make this faster without patching the speed of light. And that's not happening anytime soon. So, what we've been working on is something that I call Superchase. And in Superchase, the actual technical description is that you set not just the CD bit, checking disabled, to 1. You also set what's called the RD bit, the recursion desired bit, to 1. And what happens is when you do both, the server says to you, oh, you're looking up www.foo.com. Hey, why don't I just send you all the records that get you all the way to the root? The server has to know anyway, because it has to go ahead and have that list in order to do its own validation. Why doesn't it just send it to you? And so that's actually what we're looking at, and there are some neat facets for how it'll work. It actually requires effectively no protocol modifications. It's very nice. What's less nice is that there are very non-compliant networks out there. The basic functionality that is supposed to be in your local resolver to allow you to get even the first hop of a chase train. Yeah, it just might not implement that. It might be some little box in a hotel. Man, there is nothing worse than a hotel network. You're lucky you can like browse Google on that stuff. Local network might block traffic. And this is, in fact, your problem. Why? Because it comes back to the ops guy. You have some user who's depending on DNSSEC working. They show up at a hotel, and the network doesn't work. You know what they do? They call the help desk. You know what that does? It costs money. So, ops is king, and if we don't deal with this, hey, you know what? They'll just not deploy the stuff. So what's our next approach? Tracing. Tracing, now look, in chasing, you start at the bottom and work your way up. In tracing, you start at the top and work your way down. If this sounds like exactly what a normal DNS recursive server does, it's because this is exactly what a normal recursive server does. It just so happens that the NLNet guys took their name server built on LDNS called Unbound, and they said, what if we made libunbound? What if you could take an entire name server and pack it into a little library that could be called by any application sitting on your phone? This is actually kind of cool. Instead of 8 lines of code, now we're down to 3 lines of code. Basically, you create a context, you add some trust anchors, and you call. And it just comes back and says, oh yeah, I got that, here you go. And you get a very nice API as a programmer to build this into your system. Now what's the problem with tracing? Well, the biggest problem is it entirely bypasses local cache. This increases the load on the root and on the TLD servers. Now, if the cache is really long-lived, if they're very careful about it, maybe this could be only mildly bad. But there's always a risk. Someone's going to say, oh yeah, every time you hit this button on the phone, the root gets pinged. And then the root melts down in a fiery explosion. So let's not do that. This, by the way, was the problem with DNS curve. Dan Bernstein's brilliant. And people act like I had some kind of thing against Dan Bernstein. Do you realize how hard I lobbied for his 1999 fix? Like, seriously? It's been like hours. Like, nope, can't do this one either. Doesn't work. Got to do what Bernstein said. The problem with DNS curve is if you want this sort of end-to-end trust, and believe me, I'm just not interested if I don't have end-to-end trust. I'm not trusting some random box at Starbucks. Then you need, in DNS curve, you can't use the local caches. You have to repeatedly trust some other host and go to the root potentially. My answer to that was, no, I can't do that. So the other problem is middle boxes. It's not like they're going to be very nice to you just because you're not talking to in like. So the same middle boxes that interfere with chasing will interfere with tracing. This isn't theoretical. I was at a hotel like 3 hotels ago. You got a problem when you define your life in terms of how many hotels ago it was. Yeah, those middle boxes, they'll do terrible, terrible things. Just show up on a network. Who knows what's going to get through? So I keep talking about Skype's law, and it occurs to me, what about DNS over HTTP? It's not a complicated suggestion. Instead of doing DNS over UDP packets that might get intercepted, what if we go over the Universal Tunneling Protocol, HTTP? If the net was frozen in 2001, let's use the one protocol that was not actually frozen in 2001. Now, I know what you're thinking. You're thinking, Dan, you and your tunneling. Yeah. But no, beyond that, you're probably thinking the performance implications of tunneling large amounts of DNS traffic over HTTP must surely be enormous. And by the way, I mean, this is implemented. This isn't a theoretical thing. It's in the Freebird server now. So how much does the HTTP tunneling slow things down? 10%? 20%? 50%? 90%? Well, so I got the actual data. It actually makes it faster. What? Yeah, apparently DNS over UDP, you'll get like 3,300 queries a second on this little box. DNS over HTTP, you'll get 3,900 queries per second on this little box. So it ain't slower, might be faster. Now Paul Vixie thinks I'm wrong. Like says, no, Dan, on big I internet, this can't possibly be the case. And he might be right. Look, being wrong is fine. Being wrong just means the world is more interesting than you thought it was. It's cool. There's tons of stuff in this talk that might be wrong. Even with a significant penalty, though, Superchase over HTTP should actually work pretty well. And so within the next couple of weeks, Recursion Ventures is actually going to put a DNS over HTTP service up in the cloud. You know what? DNSSEC has to work. If it means we've got to help people tunnel their way to get DNSSEC chains, well, bring it on. Wrapping. Wrapping is cool. So there's this Kiwi, New Zealand guy. For those not in the know with the Kiwi name. Brett and I basically sat on the phone for about an hour and a half. And Brett's a real skeptic about DNSSEC. So was I. So we got along well. And Brett says to me, you have to be willing to separate the content of DNS from the transport of DNS. I'm like, that's actually a very interesting observation. So this led to an interesting concept. When you connect to a website, a secure website, the certificate is delivered to you over SSL, and well, you can sort of trust it. We basically had to deal with the realities of SSL certificate authorities, where they're a little bit hard to work with, and their security value is limited because there are potentially hundreds of them. They've sold off the rights to issue certificates, thousands and some unknown thousands numbers of time, and you can't exclude the bad guys. If you, at the end of the day, VeriSign gives you a domain for a certificate, so can GoDaddy. So if you want more details on what's wrong with X509, I'm not going to recapitulate my talk from last year, but there's a reason why we're not all using certificates every day. Turns out, X509 can carry the DNSSEC chain. Look, SSL already moves X509. Might as well put some DNSSEC inside, giving us DNS over X509 over SSL. Take that, hotel mini boxes. It turns out this is not just a very powerful way to get through networks and get the DNSSEC chain out through any kind of firewall. It also is really fast, okay, because you're basically inlining the trusted information. Only before the trusted information had an indefinite number of forms, now it's just give me the DNSSEC trust chain, period. Implementing this requires two things. First, you have to actually extract all the necessary records. This wasn't too bad. I got that working. But taking this morass of key material and saying,